Hi, everyone. My name is Alex Horn, and today we're going to be talking about some new trends on using the cloud for HPC workloads. To start, we want to begin with the forecast. We are in the process of updating our forecasts, but they won't be available until the next month or so. So just to reiterate, I know many of you have seen this before. The top row is our most up-to-date public cloud forecast. It shows about a 17.5% CAGR over the next 5 years. And we are expecting this growth to continue, if not increase in the coming years. For those who haven't seen our forecast, or just as a reminder for those who have, the way that we track the public cloud from a market forecast perspective is from end user spend. These numbers do not represent infrastructure build out, but rather they represent what end users are spending with public cloud providers to run HPC workloads off-prem. Right now, roughly about a third of the cloud spend is for additional storage, and 2/3 is for the compute. Digging a little bit deeper into storage, in 2019, there was a total of just under $4 billion of cloud spend, and about 1.3 billion of that was for add-on storage. The total cloud spend is set to surpass on-prem storage spend in 2024. We'll see that kind of visualized in a couple of slides. But also just looking at the growth rates, the on-prem storage growth rate right now is about 8.5% for a 5-year CAGR. And in the cloud, it's at 17.3%. One of the things that I wanted to show is what might happen in the next few years. We're collecting a lot of information about drivers and growth for HPC Cloud, and we wanted to look at what happens in a hypothetical situation where there's a new tipping point or a new major growth spurt. Between 2018 and 2019, there was a major shift in the market. There was an uptick of usage, both from new users and from current users, and we saw about $1 billion influx into the HPC spend on cloud. And as we look out over the next 4 years, we do expect there to be another growth year, similar to that, another major growth year. So what the blue line in this graphic represents is the potential for a future major growth year. We have it happening between 2021 to 2022, but as you can see, the blue line, which is hypothetical, if you compare that to the orange line, which is our forecast, it shows a rather significant growth year from 2021 to 2022. And these are some of the drivers that we looked at in trying to understand when this growth year might happen. One of the most important ones is a dramatic improvement in running hard HPC jobs. The tightly coupled large-scale MPI-based jobs do not run right now as cost-effective in the cloud or performant in the cloud as they do on-prem. But a change in that, if those jobs are easier to run at scale and more cost-effective, that may push a lot of users to take advantage of the cloud in a larger way. The other thing that we're tracking right now is the cost effectiveness and the cost transparency of running jobs in the cloud. There are cases where users don't understand how cost scales as an application scales, but also in looking at which workloads and which applications fit the cost effectiveness of the cloud versus on-prem based on things such as time to solution, staying within an R&D cycle, running on more performant hardware, to just name a few kind of driving forces there. And then finally, we're also tracking the growth of AI applications in the cloud. Many of the HPC users are looking to the cloud providers as access to data, access to different hardware and software, and access to expertise that may not be available on-prem, specifically for those new AI applications. And we think that's a high growth area for HPC in the cloud as well. If we break it out by verticals, the biosciences and the CAE, or the manufacturing space, were two of the early adopting verticals, and will make up a large portion of the 2024 HPC cloud market. We are tracking some specific verticals that show high growth, including the geosciences or the oil and gas and energy space, the DCC space, the digital content creation and distribution, as well as the weather space. There was a recent announcement about UK Met and Microsoft Azure, and we're tracking that situation as well as other weather applications being run in the cloud, because we think that's one of the growth areas right now. There's two charts on here, and I'll walk through both of them. What you see on the left is a breakdown of the entire broader HPC market. So that includes on-prem, server, additional storage, services, middleware, and applications, as well as the public cloud spend. And as you can see over 5 years, the public cloud spend grows as a portion of the overall market, including all on-prem and off-prem spending. On the right side of the screen, you see what 2021 looks like if you incorporate all of those factors. So public cloud spend represents about 16% of the overall broader HPC market, including cloud, just behind additional storage and just above applications. On-prem server spend still represents a large portion, the largest portion of the broader HPC market. Building off of that and looking at how the rest of the broader market, including cloud, but excluding the on-prem server market, how it has shifted or is anticipated to shift over the forecast period. As you can see in 2019, public cloud spend was the third largest category behind both applications and add-on storage. And by 2024, public cloud spend is anticipated to be the largest segment of spending for everything excluding on-prem servers, and second behind those on-prem servers. Another interesting thing we've been tracking is the ways in which the public cloud has impacted on-premises purchasing. Today, public cloud resources are complementary to on-prem deployments. This is across many longitudinal studies that show that the cloud right now is being used primarily for burst capabilities, for increased resource capabilities by HPC users. But a recent study that was completed in early 2020 showed that almost half of the users are altering their on-prem deployments due to cloud considerations. And we're asking more questions, and we're diving a little bit deeper into this topic. So look for some more news and announcements and research on this topic in the coming months. One of the key kind of barriers, or the ways that in which cloud has impacted on-prem, is the expertise and the skill sets required for moving or migrating to cloud platforms. Many on-prem data centers don't have the expertise, they don't have the education in how to take advantage of running in the cloud. So there's a learning curve, and then there's also the data movement and the security. And we're going to talk about some of the barriers in coming slides. But as data sets get bigger and as AI becomes more important, the ability to expand your resource pool is going to be critical, and that's where the cloud can play. So speaking of barriers, the number one barrier still remains cost to taking advantage of the cloud. Cloud computing can be very expensive for certain workloads, but there are workloads where, as I mentioned earlier, the cost effectiveness balance is becoming lower. And there are options like spot instances or preemptive instances that allow for low cost cloud computing. Again, that doesn't make sense for every workload, but there are workloads where that type of cost and compute model is effective and can in some cases be more cost effective than on-prem. And this is something that users are evaluating right now. Another major barrier is some of the data issues, including data locality, data gravity, and data movement. Upload and download times can be extremely long, but also data movement in and out of a cloud and within a cloud platform can be very expensive. And then finally, security is usually in the top three in terms of important barriers. And it's growing in importance, especially with new data privacy laws around the world, including GDPR and things like HIPAA and FedRAMP. The need for regulating where data is, controlling either the state, the country, the region that the data resides in is extremely important, and keeping that data secure is important to these HPC users. On the flip side, if we look at some of the drivers, I already talked about burst capabilities, but that is the most important driver for cloud adoption, the ability to increase your HPC resources elastically. The second one there, cost effectiveness, this has been growing as users continue to understand and learn which applications make sense and are cost effective in the cloud and which ones should stay on-prem. In some cases, applications that require expensive hardware that's not available on-prem can be more cost effective to run in the cloud because the hardware, you're renting it instead of making a large investment. So if you don't need that hardware full time, but you want to take advantage of custom accelerators or different types of node configurations, experimenting and running some of those workloads in the cloud can be cost effective. And building off of that, another thing we're seeing is users experimenting with some of these new hardware and software platforms for potential future on-prem deployments. We're seeing this a lot in the AI space as users experiment with different accelerator technologies. As we look forward at the next 6 to 12 months, there's a couple areas we're looking at in terms of future research. One is we're trying to get a better sense of not just user spending and CSP consumption, but also a breakout of the different CSPs. What does the market look like from a spend perspective? We're also trying to get more information about the differences between the verticals and the different user types that are taking advantage of the cloud. An area that we're focusing heavily on is the storage aspect of HPC cloud computing. So what are the requirements for parallel file systems? What is the sentiment and opportunity for kind of leading high performance file systems? What are the different options for storage kind of capabilities if you're looking at file versus block versus object? Are there different use cases? Where are users optimizing the different storage options? And how is that playing out? So to wrap up, cloud continues to be a high growth market. Users are increasingly taking advantage of the cloud for workloads, for HPC workloads, especially as they start to understand and investigate which are cost effective and performant in the cloud and which should stay on-prem. Many of the barriers have remained consistent over the last few years, but one important one has kind of decreased in its importance to users, and that's performance. CSPs have improved their performance on HPC applications greatly over the past few years, and it's kind of narrowed that list down to the 3 barriers we talked about earlier. And then finally, as I touched on earlier, given some of the recent announcements, the weather sector is one that we're watching very closely, not only for the potential for their increased usage, but also as a proof of concept group for the capabilities of cloud platforms for running some of the harder HPC applications that we see. Thank you very much. And if you have any questions or comments, please feel free to reach out to us and we'd be happy to talk.